Here we have question 6 of exercise 2.2, and it is a separable differential equation. You can separate the terms of x and y by moving any of these terms on the other side of the equal sign. So I am moving this minus dy by dx on this side and this 2xy square on this side. From here I can move this y square here, y square, and I will have dy here, and this is 2x which will be here, dx will move here, and now I am moving this constant, this minus 1, which is multiplied with this term on the right left side, because I want all the constants with x. So from here you can take integral of both sides. You will have integral of minus 2x dx, and you will have integral of 1 by y square dy. From here you can write this, you can take this minus 2 as common, and you will have x squared divided by 2 dx, and on this side you will have integral of y raised to power minus 2. From here you can cancel these two terms, and eventually you will have this. Okay, here I must not write this. I must write the constant of integration here. So you will have a constant of integration here, and on this side you will have minus y, which is the integration of this. And now what you can do, okay, raised to power minus 1, you can turn it to this and plus c. From here you can multiply the whole equation by minus 1. You will get minus c equals to 1 by y. Now this minus c, you can write this as plus c1, and on this side you still have 1 by y. Now if I move y on this side, and if I do cross multiplication, I will have y on this side and x squared plus c on this side, and this is our solution. Now question 7. So in the 7th question, it is a little bit different. It's in an exponential form, so you can write this term as this one according to the rules of exponential, and here dy by dx. Now I want to separate the terms of x and y. First of all, I am simply moving this dx on this side, so I will have e raised to power 3x multiplied by dx, and this thing multiplied by 2y. If I move this 2y on this side, I will have this term in the denominator, and from denominator I can move it up, so eventually I will have this here and this here. So very easily we have separated both of these terms. Now we need to integrate them. So if I take integral on this side, minus 2y dy equals to, and if I take integral on this side, dx dx, what I will get the same term here and only minus 2 in the denominator. And okay, if I put constants with the x, I will have e raised to power 3x divided by 3 plus c, and from here you can move this term on the other side here. You will have minus 2y and divided by minus 2 minus e raised to power 3x divided by 3 equal to c. Now you need to take, okay, so 6 here, and you will have minus 3 here, minus 3 e raised to power minus 2y, and you will have minus 2 here, minus 2 e raised to power 3x, and on this side you have c. So now what you can do, I am taking minus as common from here, e raised to power 2y minus, okay, plus 2 e raised to power 3x equals to 6c. You can write this 6c as c1, and you will have a different, okay, you can multiply this minus, you can move this minus on this side, you will have minus 6c, and eventually you can write this whole thing as a minus 6c at c1, and on this side you will have 3 raised to power 8 2, I think minus 2, sorry, minus 2y plus 2 e raised to power 3x, and this is your solution. Okay, now eighth question, and within this question we again have exponential, so let's do it. First of all, I can write this term as this one, okay, and from here I can take e as e minus y as common, so it will be 1 plus e raised to power minus 2x. From here I can separate my terms. I am moving this minus e raised to power x on this side, so I will have e raised to power minus x from the other side, 1 plus e raised to power minus 2x, and a dx from the other side. And on this side I will have this e raised to power minus y, e raised to power y now, and then y and dy. I have separated the terms, and now I just need to apply integrals on the both sides. So integral of e raised to power y, y dy, and integral of e raised to power minus x, 1 plus e raised to power minus 3x 2x, and dx. So by applying integration by parts on the left side, you will have y e raised to power y and minus e raised to power y. Okay, and on this side I am multiplying this e raised to power minus x within these two terms with these two terms, and I will have minus 3x dx. So from here, if I take this integral separately, I will have minus raised to power minus x plus, okay, not plus, it should be minus e raised to power 3x minus 3x divided by 3, and constant, and on this side you still have minus e raised to power y. Okay, so in this way you would have you will have y raised to power, okay, so this one, and this ex will be positive on this side, and you will have e raised to power minus 3x divided by 3. Let me know if there is any mistake. So here you have your solution.